Hello, everybody, and thank you for joining me in this presentation of the NASA Astrophysics Data System, a search engine for the scholarly literature in astronomy and related areas. My name is Alberto Comazzi, and I'm the PI of the ADS. I'm making this presentation on behalf of our entire team. What is the ADS? It's a digital library for research in astronomy, but it includes literature in other related areas such as heliophysics and planetary science. We currently have 15 million bibliographic records covering all of these disciplines, plus additional areas of physics. The system tracks citations, and we have over 130 million citations currently tracked. We also have over 500,000 links between papers and astronomy data products, as well as bibliographic collections for all the major astronomy missions and projects. The system has collected over 20 years of usage data that we use to make recommendations to our users. The new ADS was launched over a year ago, and it's a new modern system that provides an interface and additional search capabilities. We index over 6 million full-text documents, and we allow people to search by fields such as institutions and even the acknowledgement section. The interface allows exploration of topics and collaborations through a number of different visualizations and provides metrics for evaluating the impact of research. The system also integrates the ORCID claiming for author disambiguations. The interface is available at this URL, ui.adsapps.harvard.edu. One of the most common ways to search the literature is to look up papers by author name. Our page provides a number of examples for how to formulate those queries, and also some convenient shortcuts to help you create the proper query. For instance, if I'm interested in papers written by Michel Mayor, I would simply type the following query and get a list of over 1,000 results. I've currently configured my account to return results in the physics and astronomy collection, but if I'm only interested in astronomy papers, I could remove the physics collection filter, and this would bring down the list of results to just over 1,000. On the left, you can see a number of additional ways to filter the results. In particular, if I'm interested in papers about particular objects, I could look and open the simbit object filter and then find a particular star, galaxy, or in this case, exoplanet that I'm interested in. Let's say I'm interested in 51 Pegasus B. I could select that and click on the limit button to further refine the results to have only the ones that contain references to 51 Pegasus B. All of the papers in this list have been indexed by the simbit project as having something to do with 51 Pegasus B. And the oldest of them is a Nature paper that announced the discovery of this exoplanet, and one of the reasons why Michel Mayor won the Nobel Prize. This particular paper has been cited over 2,500 times, and the interface shows all the available links associated with the paper. In particular, we can see that there are datasets hosted by the simbit database and by the NASA Exoplanet Science Institute. By clicking on the link, you go directly to, in this case, the simbit page that reports results for this particular paper. And as you can see, we can find measurements for the host star and the exoplanet. Just as easily as you can apply a filter, you can also remove it from the result list. So by removing the restriction on 51 Pegasus B, I'm back to my original list of results, papers written by Michel Mayor, and in the astronomy collection. I can also re-rank the results based on criteria different than publication date. For instance, I can sort it by citation count to find the most cited papers on top. And I could also further narrow down the list to see only the refereed papers belonging to this list. This cuts the total list of papers in half to just below 500. Having seen this list, I can now look at, for instance, additional metrics associated with them. For instance, citation metrics that will provide an overview of the impact of these papers in terms of number of records and number of citations associated with them. Here we have a histogram of all the refereed papers that Michel Mayor wrote over his career, and this is a distribution of the citations to these papers broken down in refereed versus non-refereed citations. Additional ways for visualizing and normalizing these citations are available, as well as a breakdown of all the citation metrics in this useful table. There are additional visualizations that we provide. For instance, the author network will show a rendering of all the collaborators that have worked and co-authored the papers in the original list. In this case, all the papers were written by Michel Mayor, so he's the focus of this diagram. And around it, we see a clustering of different authors based on how frequently those authors published together with Michel Mayor. In this case, our algorithm has selected a number of authors in this blue wedge that have most frequently published with Michel Mayor and are responsible for a list of 339 total papers. Other collaborations have generated a different list of papers, and the summary view provides an overview of the frequency, a histogram of the frequency when these papers were published over time. The visualization allows one to resize the wedges based on how many citations the corresponding papers have received over time, or how frequently those papers have been read and downloaded according to the ADS logs. Going back to the original sizing, we find simply how many papers were written by the original groups. Another popular way to search the ADS is to look for papers concerning a particular topic. Let's assume I'm interested in papers about the atmosphere of Jupiter. So I may issue a query such as this one, Jupiter atmosphere, and once again limit myself to the astronomy collection. In order to have a better sense of how the papers in this list discuss the atmosphere of Jupiter, I can press on the button that says Show Highlights. This will generate text snippets that show how my search terms appear in the context of each paper. And this is a very brief summary of what is found inside the papers. It takes a few seconds because the papers need to be retrieved and marked up for this display to appear. As you can see, some of these papers concern the actual study of Jupiter's atmosphere, but some other ones are related to exoplanets, such as hot Jupiters, for instance, which may not be what I'm looking for. In that case, one can further refine the query, for instance, adding another clause that excludes the selection of hot Jupiter papers. And this would narrow the results down to be just below 4,000. One feature of our system that a recent feature we've introduced is the ability to create notifications for new papers appearing on a particular topic. If you're logged in, then you can create an email notification so that you will receive updates from ADS on a daily or weekly basis. I'm going to name this notification Jupiter Atmosphere and create a weekly notification that is reflected in the profile of notifications that belong to me personally. As you can see, I now have 7 different queries that will generate notifications on either a daily or weekly basis when some of the conditions outlined here are satisfied. In this case, I added a general type query to my weekly email that will be delivered usually during a weekend when new papers are added in ADS. You can also add daily papers that come out on the archive, or citation and keyword queries that appear on a weekly basis from the published literature. If you want to know more about additional features implemented in our system, I recommend that you check the About link, and you'll find a menu of different options, including help pages and blogs that were written about the system. All new features will be discussed in the blog, including the MyADS notification service that we just discussed, and the introduction of new features and new insights into the data represented in the ADS. I hope you enjoyed this presentation on the astrophysics data system. If you have more questions or you want to find out more about our services, please go to ads.harvard.edu or look us up on Twitter @ADSApps. Thank you.